Good evening. Thank you so much for joining us tonight on Twitter, YouTube, and Facebook. I'm Maryn McKenna. I'm a journalist and author and a senior fellow in the Center for the Study of Human Health at Emory University. Welcome to the first episode in the 2022 edition of our Author Q&A series, which is a project of the Center's Health Storytelling Initiative and is co-sponsored by the Georgia Center for the Book. My guest tonight, whom you'll meet in a minute, is Dr. Jo Handelsman. She's a biologist, the director of the Wisconsin Institute for Discovery at the University of Wisconsin-Madison, and formerly the associate director for science in the White House Office of Science and Technology Policy during the Obama administration. Her new book, from Yale University Press, is A World Without Soil: The Past, Present, and Precarious Future of the Earth Beneath Our Feet. I'll be talking to Dr. Handelsman about the book, but also about her career, about the situation of women in science, and about her groundbreaking project to crowdsource antibiotic discovery by recruiting the help of college students, which is called Tiny Earth. First, let me do a bit of housekeeping. In the first half hour of this chat, I'll ask questions of Dr. Handelsman. In the second half hour, I'll ask some of your questions. Type your questions into the comment box of whatever platform you're watching this stream on. And our producer, Stefan Kaplan of Spinnet Social, will display some of the questions on screen for me. You can ask a question at any point, but be aware that we won't turn to audience questions till we're halfway through. We'll do our best to get to as many as possible. So let's get started. Dr. Handelsman, I am so thrilled that you could join us tonight. Let's dive right in. I usually ask people to talk right away about their book, but your career is so fascinating that I'd really like to start there. Can you give us just a bit of how you got to be where you are? You started at one university, you were in the Obama White House, you were at another university, but I think we should probably go back before that to wherever your engagement and enchantment with biology starts.
Well, thanks for having me, Maryn. It's great to see you. I think my moment of transition, when I went from being someone who was maybe afraid of science a little bit, not that interested, to someone who was addicted for the rest of my life, was when I was 12. I had a class, a biology class, and we looked through microscopes one day. And I saw a paramecium under the microscope, and I just thought it was the most charming creature I'd ever seen, and I never wanted to leave the microscope. And so I've been playing with microscopes and microscopic organisms ever since. That's where I started. Then I went through probably the sort of standard route that many people, but certainly not all, take into science. I went to college and then graduate school. And then I was fortunate enough to get a faculty position at the University of Wisconsin. And I was in the Department of Plant Pathology, which was not where my training was. I'm more of a molecular biologist and microbiologist. But they had a very broad definition of what a plant pathologist could be. And so it was a really engaging and inviting department because it was just so inclusive of a very broad range of science. And I was there for many years, and then I chaired another department, the bacteriology department at UW-Madison. And then Yale came knocking and asked me if I would move to Yale. And so I did. And 4 years into my time there, President Obama called up, or his science advisor called, and asked whether I would come to Washington and be a member of the science advising staff. And at first I wasn't really interested in that. And I thought, how could I leave my lab and my teaching and all the things that I'd worked so hard to set up at Yale, and things were going really well. But my husband and John Holdren, who was eventually my boss at the White House, convinced me that this was a really good opportunity to influence the broader agenda in science, which I had been trying to do from the sidelines for a lot of my career. but this was obviously a platform unlike any that I'd had before. So I ended up accepting it, and I went to Washington, moved to Washington, and worked in the White House for the last just about 3.5 years of President Obama's term. And then afterwards, I was offered this amazing position at the University of Wisconsin-Madison as the director of the Wisconsin Institute for Discovery, which is just a wonderful opportunity, kind of an experiment in scientific research. And so I came directly from the White House back to Madison, and here I am.
So I think that probably a lot of people who are watching this don't actually know what the Office of Science and Technology Policy does. So fill us in on that a little bit.
Well, probably most people don't. I certainly didn't. If they do know, they're way ahead of where I was. I had a vague notion about the office. We really had 3 major missions. One was whatever the president needed at the moment. You know, if he wanted a briefing or a memo on a particular topic, whether it be genomics or virtual reality or something else, we would prepare an in-depth memo or briefing on that subject. So whatever he thought was important, obviously, was top priority. But when he wasn't specifically asking for something or directing us to follow a new initiative, we had a lot of flexibility to pursue new initiatives that could be pursued in many different ways, some through federal funding sources, some through collaborations with private industry or private foundations or philanthropic donors. Some just by making the topic visible and taking a position and putting the weight of the White House behind it. And so that was, of course, very exciting because you know, we had all the science in the world to draw from. I was running the science division. That's pretty broad description, from telescopes to agriculture and everything in between and around. And then there was the third area, and that was the emerging problems. And the years that I was there, those problems ended up being 2 pandemics. One, Ebola, which was, of course, in Africa, and the United States played a major role in responding to that, particularly in Liberia, which is one of the 3 countries that was affected. And then we were just coming off the Ebola crisis, and we kind of had gotten it under control, and then Zika virus showed up. So I am a microbiologist, and there actually had not been a microbiologist in the Office of Science and Technology Policy before I got there. And so I think we all thought it was kind of fortuitous that we had a little bit of expertise. I'm not a virologist, so I had to learn an enormous amount to deal with these epidemics. But that was the job, is learning whatever it was that was needed.
So in the beginning of the book, in the prologue, you write about an initiative that you wanted to take in that office. You describe it as the memo that I wanted to send to President Obama. And that memo kind of turns into the book in which you're addressing sort of everyone else in the world other than President Obama about this issue that you're so concerned about. So tell us about that memo and why you never got to send it.
Well, I started studying the issue of soil science from a White House perspective once I got there. And I knew I wanted to do something in soil science because it's an managed, underaddressed, underfunded area of science. And so I knew there was a lot to do there. But what I hadn't realized, even though I've been in soil microbiology and various other aspects of soil for decades, was that unlike what I believed, which was that we had conquered the soil erosion problem back in the 80s, we actually had not. We had slipped back in terms of our management of soil. And the result was that soil is eroding very quickly. So at first I was sort of shocked that, wow, how did I miss this? I'm a soil scientist. But, you know, we're all kind of siloed in our areas of science, and we focus on those, and we don't often have the opportunity to go broader. And so I grew up as a soil scientist in an era when a lot of new technology was coming down the pike that would protect soil. And so many of us thought, oh, the soil erosion problem is over. And it really did start going away in the 1980s pretty effectively. The erosion rates were just dropping steadily. And then because of different legislation, it started getting worse again in the 90s. So that was my first reaction, was, wow, I missed this. And then the second reaction was, I have to do something about this. So I talked to a lot of experts across the country and tried to learn what would make a difference. You know, what could the federal government do that would actually alleviate the crisis in soil? And I wrote a memo to the president, and that usually was the starting point for a presidential initiative. And so there are office initiatives that come from the Office of Science and Technology Policy. There are White House initiatives, which are backed by the whole White House. And then there are presidential initiatives. And I, of course, wanted a presidential initiative because I thought this was one that would actually really interest President Obama, in addition to needing his support to move it forward. And I just couldn't get the memo off the ground floor. And everyone said, oh, it's kind of late in the administration. You can't really start something that big and that new at this point in the administration. But of course, my whole tenure in the administration was kind of late. It was the last few years. So I think if I had been there at the very beginning, I would have been able to launch it at a presidential level. And as it was, we had a very successful event, but it was a White House event, not a presidential event. So we didn't have the force of presidential backing.
I think at this point, it would be wise for us to talk about soil, which is for most of us nothing more than the dirt beneath our feet. But as I read your book, I realized that maybe for the first time that soil is really wondrous. It's magical. It does so many things that we completely take for granted. I think you should talk to us about that for a minute.
Well, one of the what you call magical, and I agree, but also is just science, parts of soil, is that it's so complex. It's probably the most complex habitat in the world. And the reason for that is that it's constantly changing. So it's a mixture of the rock from bedrock and subsoil and all of the what we call the material that they gave rise to soil, the geologic material. And then organisms have begun to grow in the soil. So it's the result of many years of plants growing, microbes growing, animals growing, and then all of those organisms dying. And so in any moment in soil, we have this just amazing mixture of rock that has been weathered and changed by the physical environment, changed by the chemical environment, which in turn is shaped by the organisms that live there. And then it's this chaotic mix of organisms growing, static, and dying. And then, of course, there are all the cycles that result from that. And when the plants die, the microbes eat them and turn them into other compounds. Same with the animals. And so there are just these incredible cycles of reusing nutrients and responding to all of the changes. So, of course, soil is subject to the radical changes in temperature, the very rapid changes in water. That's probably the single most evident change that soil organisms face, is that you can go from drought conditions to flood conditions in a few hours in some environments. And just every day there's a change in the water status of the soil. So it's complex in any snapshot in time in terms of all the different things that are there. But then it changes. And so what it is in one instant is different from another.
You write early in the book, and I'm going to read this because it's such beautiful language, and it's also so critical to the message that you want to impart, that no plant or animal, oil or coal deposit, waterfall or towering mountain contains the vital force or intricacy of soil, and few features of the world are as hidden from view or as taken for granted. Soil is the dark matter of our planet. It's gorgeous, but it's also so true. I mean, I don't think any of us, at least if you're not a farmer, or maybe a drug developer, we'll talk about that in a minute, have thinks about how critical soil is to our lives. We assume it will always be there. And yet, as you very poignantly lay out, soil is leaving us.
Mm-hmm. That is so true. I think that's one of the truest things in the book, is that it is one of the most important and vital to our survival. And yet, how many people think about soil in a day? Probably very, very few. They might walk across it. They might even dig to build a house or plant a garden. So they might have some direct contact with it. But other than that, most people just sort of ignore the soil, and they don't realize that they're walking on, you know, when you think of the ground has this very neutral feel to it. It's just that thing we walk on, and it has a utilitarian quality. And I don't think most people think about what's going on beneath their feet in this incredible community of organisms feasting on each other and on the chemical and geologic material that they live with.
So I think we should talk for a minute about this recognition that soil is leaving us, that we are losing all around the world. We are losing soil at a much greater rate than that complex mix of organisms that you just spoke of. We are losing it faster than that complex mix of organisms can recreate soil for our benefit. So you lay out in the book that there's many pathways through which that is happening. And I would love it if you would recount some of those for us.
Sure. The main premise for the soil loss is the rate at which soil is produced, which sadly is very slowly. And as wonderful as those microorganisms are, there's a limit to how fast they can break material down and transform, and that the weather can transform the geologic material. So we think that about roughly something like a centimeter of soil is formed every 100 years or so. And so if you think, or in inches, it would take a couple to a few hundred years to make an inch of soil. And so that's very slow. And at the same time, we're losing inches per year in many, many parts of the world. So if you're losing inches and you're only making half an inch max per year, then you really, or much less than that, then you really can't balance that equation. There's only one way for the soil to go, and that's down. In most parts of the world, we calculate that the soil loss is about 10-fold to 100-fold faster than soil production. And so that's the nature of the calculus, that we just can't possibly be keeping up with the rate at which we're losing it. The soil organisms just can't work that fast. And that comes from lots of different evidence, different ways of measuring the soil and figuring out how much is moving off our agricultural land, and then from many different uses, but predominantly from agricultural uses.
Let's talk a bit more about that, because, of course, the way I phrased this when I said we're losing soil, it's sort of a statement without agency, as though soil is just poof going away from us and no one is responsible. But in fact, this is not an inevitable process, but rather something that is occurring as a result of social and policy choices we've made.
Yeah, very much so. So, you know, gravity, it probably is the single biggest opponent of soil. So as water impacts on soil, it dislodges the particles and can move them downhill or into a different place, into streams, rivers, and ultimately into the ocean. So water movement is the primary cause of soil loss. The antidote to that are trees and plants. And once the soil is covered with a forest, for example, it becomes much more stable. So one of the first causes of soil erosion was deforestation, because losing those enormous tree roots that anchor the soil and feed the soil was the first disruption. And then the other, of course, is agriculture, where some of it is land that was cleared of trees. Some of it is land that was in prairies or steppes or other environments. And the disruption of those natural environments and the digging in that soil with particularly plows that disrupted and degraded the soil, reduced its architecture, its 3D structure. Those are the factors that really made it vulnerable to the effects of weather, mainly water, but also wind. As soil dries out, the particles separate and they can be taken off by the wind at a pretty high frequency.
It's very poignant to me that you, of course, invoke the Dust Bowl in the 20th century America in your book, but you also talk about how the loss of soil to processes, to varieties of agricultural production, and possibly also to climate, caused that kind of soil loss repeatedly through history, that the Dust Bowl was not a one-time thing, and our mistakes around handling and managing soil are not a one-time thing either.
Mm-hmm. Yeah, there are people who argue that societies have consistently collapsed after usually a couple hundred years because of the way they treat their soil, that's about how long the soil lasts in intensive agriculture where there's plowing. And so, yeah, we've repeated that over and over. In the United States, there are really easy examples of where you can just follow the migration trail of people. And it was due to the exhaustion of the soil. And one of the most dramatic examples is the Piedmont area, where the very steep slopes in the eastern part of the Piedmont were deforested and then put into agriculture. And it was very intensive agriculture. It was row crops that, require a lot of plowing and care. And after a number of years, those areas became unfarmable. They just wouldn't produce anymore because the soil had left the site. It had been washed downhill. So those people who were in the far eastern part of the Piedmont started moving west. They did the same thing again, deforested, grew crops. The soil was exhausted, and then they moved further west. And so that's an example. And the Piedmont has never gone back into agricultural production because the soil was so badly damaged and so degraded and eroded that it was just impossible.
That's such a poignant image. We're in the US, we're raised to think of the way that the first settlers moved west, and that it was an expression of agency and manifest destiny and conquering a foreign land, most of which we now know to be untrue. But it's almost the mirror image of it, that what those early settlers were doing were exhausting the land and just staying ahead of that degree of exhaustion they had inflicted on it in order to find some new patch of soil to exhaust in turn. It's kind of horrifying.
It is. And when you couple the horrifying loss and damage to the soil with the damage they did to the people who lived there, and all the indigenous populations that were totally displaced or killed, it's an even worse image, and it's pretty discouraging to think of the way that we have told ourselves stories about that process. And yes, there was, a pioneering spirit, and it was very, I think, quintessentially American, in the way a lot of people like to idealize that period. And the breaking of that land was dependent upon the steel plow, which was an invention of John Deere in the United States. And it probably would have been much more difficult. Maybe someone would have found a way, but it would have been much more difficult to settle that land and put it into agriculture without John Deere's plow. So the innovation there and the spirit of pioneering and going to a new area where people had not done classical Western European agriculture, I think does kind of bear out that very exciting image that many people like to have. But it was coupled with incredible exploitation of people and resources.
I want to be sure that we don't forget to talk some more about the the history that indigenous populations have with soil, because it's so different from this history that we've just been talking about. But there's a few more questions I want to ask first about sort of the modern era. So you described a few minutes ago your engagement with your shock when you were in the White House, that soil was being lost. And you were shocked because you thought that was a solved problem, because there had been policy initiatives 20 years before in the United States that were meant to address conservation of and protection of agricultural land, or the state of agricultural land. As you describe, those measures were undermined. They did not persist. And instead, what we got was this increasing intensification and monoculture agriculture in corn, in soy, in other crops that has actually made the soil situation worse, right?
Yes, that's exactly right. You know, when I went to college, no-till farming had just been introduced, and I was in an agronomy department as an undergraduate. And I remember people talking how exciting it was that we could get rid of the soil erosion problem just by moving to no-till agriculture, which means simply not plowing. And there are now alternatives to plowing. And people really talked like the problem was done, which is why I was kind of lulled into thinking that it was. And then legislation followed that in the 80s that helped farmers with the cost of preserving soil. And so that was the legislation that helped, but then other legislation came in, weakened the original legislation. And that's when in the 90s, it went the other way. And so it really is kind of a shocking history that we thought we were done with this problem, and then it really wasn't. And the rate at which it's eroding, I think, is one of the really scary parts. That not only did we not implement no-till farming on all of our land, we didn't even implement it on any more than a third of our land. Other countries have taken our technology and done great things with it. In Brazil, I think 2/3 of the land is in no-till farming. So we could have made very different decisions then, and we simply didn't.
Astonishing. So one of the things that I think people may not have thought about, I mean, it's possible that some of the things that we're talking about tonight may be kind of familiar to people. They may have heard about the Dust Bowl. They may have heard that maybe monocultures of crops are not a great thing. But I don't think people think very much about another issue that is very important in your book, and that is soil as a store of carbon. When we lose soil, we are losing one of our protections against the onslaught of climate change by releasing carbon back into the atmosphere. So unpack that chemistry for us. It's really complicated.
Well, the amazing thing is that soil contains, worldwide on the whole planet, contains 3 to 4 times as much carbon as the entire atmosphere. And that's more than all the plants put together. And the only thing that holds more carbon than soil is the oceans. So this is not a trivial source of carbon or reservoir for carbon. And the other thing is that we have taken a lot of that carbon out of the soil. It's thought that we've removed about 133 billion tons of carbon from soil in the last couple hundred years. So there's clearly a lot of storage room left, right? We made room for it very effectively. And so we have the capacity to put that carbon back into the soil. So the chemistry of it is that plants are the major fixers of carbon on terrestrial land. And so they take carbon dioxide and convert it to sugars and other compounds using the energy of the sun to drive those reactions. What most people don't know, I think most people are familiar with that, but what most people don't know is the part that's hidden. And again, we can't see it, so we just ignore it. And that's that plants put as much as 1/3 of the carbon that they fix into their roots and out of their roots into the soil. And that has probably evolved to feed their microbes, that they feed the carbon from their roots to the surrounding soil organisms, and they thrive and live as a result. So it's a great symbiotic relationship between the microbes and the plants. But that carbon going from the plants into the soil is a very important part of the entire carbon cycle. And the roots themselves, and for example, the tree roots are so effective at holding the soil, but they also hold a lot of carbon. And so when we deforest, we not only lose the carbon fixation capacity in the upper part of the tree, but then the tree roots begin to decay and decompose, and very often will be just turned into carbon dioxide, or even worse, methane, that goes off as a gas. So not all soil that leaves land releases its carbon. Some of it just ends up buried, which is bad for the soil, but it's not bad for the climate. But some of it releases its carbon, and that leads, of course, to more greenhouse gases and more global warming. And so that's the cycle, that the more we degrade the soil, the more we increase climate change. And then that in turn causes more soil degradation, because one of the accompanying features of climate change is the very severe rainstorms. And people who live in the United States, for sure, and other parts of the world have started seeing these very regularly in the last decade. And those extreme weather events are very effective at degrading the soil, reducing the aggregates of the soil, which are one of the things that keep soil in place, and then washing it away. And the force of those raindrops in those severe weather events is one of the significant features that degrade soil. So the more climate change, the more of these severe weather events, and the more of those, the more soil loss, which leads to more climate change. So it's definitely a source of carbon going into the atmosphere, but where it really has a role is potentially in storing that carbon. And if we handle the soil properly and plant the right kinds of plants, we end up putting a lot more carbon into the soil than we're taking out. And before you mentioned monocropping, and one of the most destructive plants is the corn plant. And one of the reasons is that it has these just puny little root systems. And so by the end of the season, only about 1% of the biomass of the corn plant is actually in the soil. It has shunted all of its carbon up to the top part of the plant, because that's, of course, what they've been bred for. We bred them to produce a lot of corn. And so we harvest that, feed it to animals, and we don't care, or we haven't, about what's left behind in the soil. But you compare that with the plants that were in that soil where the corn is planted now, before we farmed it. And those plants were these deep-rooted perennial plants, prairie plants. Some of them have roots that are 14, 15 feet deep. So these are relatively short plants. They're only 3 or 4 feet high, but they have these enormous root systems. And those plants leave about 70% of their biomass or their carbon in the soil at the end of the season. And then they come back the following year. That's what makes them perennials. They use all that stored energy to make a new plant and begin fixing more carbon to do the same. And so every time you go through a cycle, those plants are depositing carbon and enriching the soil, which is frankly where we got the great soils of the United States, particularly in the Midwest of the country. It was those prairie plants that gave us the soils. So corn has been the replacement for the prairie plants that's been pretty destructive to our soils.
So people in the comments are starting to ask, oh my God, what can we do? But before we get to that, there are 2 other things that I want to raise. The first is that Dr. Cassie Quave of Emory University asks, as she's watching, about peatlands and about the loss of peatlands. Surely peat is one of those naturally occurring types that is of soil that is particularly good at sequestering carbon. I believe you talk in the book about how we're losing those around the world.
Yeah, about 7% of the soils in the world are actually peat soils. And these are a really unusual soil because they're so dense in organic matter meaning carbon. And some of them go as deep as like 20 feet down. And that's because they're the result of boggy conditions that have been wet for a long time. And so under those conditions, the oxygen levels go down in the peat, in the bogs. And so plants die and they deposit all their carbon there. And then it's degraded very slowly by the microbes, because when they don't have oxygen, they kind of chug along at a pretty slow rate. If they're given oxygen, then they start really pumping out the carbon. And that's when the soil begins to shrink. There's less peat there because it goes off as carbon dioxide. And so what has happened is people have harvested the peat and they burn it for fuel in some countries. In others, they harvest it for agricultural or more often horticultural purposes, for growing plants for homes and greenhouses. And those are all nice uses, but of course, it devastates the peat supplies. So now a lot of if you look at, like, you buy a bag of peat at a garden store, it often will say harvested under sustainable conditions, particularly from Canada, because Canada is very protective of their peat. So some of it has been just destroyed that way. The others, which are really kind of scary, are peat bogs that are being burned in Indonesia. And that's to replace them with trees, rubber trees for the most part, in large plantations. And the easiest way to get rid of the existing forests is just to burn them. Well, that also burns the peat and then drives a lot of that carbon into the air. So our peat bogs are really precious for carbon storage, and we're just destroying those too at a rapid rate.
So once again, we're replacing natural diversity with monocropping, and look where it gets us.
Yeah.
The one other thing that you mentioned that I can't let go by, because it touches a passion of mine, is that you started to talk about plant and soil microbes. And I don't think most people know that that antibiotics, the drugs that changed the course of history by making it possible for us to cure infectious diseases for the first time in human history, actually began as products of soil microbes. And in fact, one reason why we have a dearth of antibiotics now is that there was a point where drug development discovery turned away from investigating soil and went into the lab instead, and found that synthetic chemistry wasn't as good as Mother Nature. And I know that you have an initiative that addresses this, so I would love to hear you talk for a bit about the unique promise of soil organisms as producers of antibiotics, and how you hope to perhaps bring that back into modern science now.
So about between 2/3 and 3/4 of the antibiotics that we're all familiar with, the ones that we use in the clinic all the time, penicillin and erythromycin and streptomycin, names that most of us have heard, come from soil bacteria. And some of them, like the penicillins, come from fungi, but those can also live in the soil. And so soil microorganisms have been this treasure trove for the pharmaceutical industry. After people began to find the antibiotics, they found that these soil bacteria also produce other drugs. And so the soil has been a source of pharmaceuticals, way beyond the antibiotics. But antibiotics have clearly been the game changer in human history that the soil bacteria have contributed. Back in the 80s, there was this kind of myth, basically, that was promulgated through the pharmaceutical industry and then through academic science, that the soil is all tapped out, there's nothing left to find. And people who have heard this just sort of bought it, lock, stock, and barrel, and said, yeah, there's nothing left to find there. And my lab continued to find new antibiotics kind of by accident. We were studying soil bacteria doing other things, and these antibiotics kept cropping up. And so it kind of dawned on me one day, how come we keep finding them if the soil is so tapped out? And maybe if we did it in a more systematic way, not just falling upon them, but actually looking for them, we would find a lot more of antibiotics. And so we started an initiative when I was at Yale in 2012 to teach undergraduate students to do research on soil bacteria. And they isolate bacteria from whatever soil interests them. They collect it from where they live or from their dorms or their campus. And they bring it into the lab and they isolate bacteria From it, they screen those bacteria for the ability to produce antibiotics. And then they characterize both the producing bacteria and the antibiotics. We also have a chemistry lab at UW-Madison, where if they want to send their isolates to us for further characterization, we can begin to study the chemistry of the compounds produced by these organisms. And it's been extremely productive as an educational initiative. But frankly, a lot of people haven't believed that we could really find new things in soil, even with what has become this worldwide workforce. We have about 14,000 students taking the course per year in 30 different countries, taught by about 700 faculty and instructors that we've trained in Madison or one of our other sites. And we know that they're finding, great stuff, and the students are learning a lot. So that part of it, we're pretty confident everyone can accept this is great experience for students. But until we have a whole bunch of new structures of antibiotics, there are still people who say the soil is tapped out. And I hear that rhetoric all the time. And in fact, there's not very much evidence to support it. And so we've just changed a few things that the industry did routinely. And some of it is the innovation from students. Students aren't bound by the 80 years of history of antibiotic discovery. So they do things differently. And all of a sudden they find they're getting a lot more antibiotics than people who were doing it in traditional ways. And then we've very deliberately changed some methods so that we can begin to see what we call silent antibiotics, ones that aren't normally produced by bacteria, produced under our conditions. So it's a very, very rich initiative in terms of discovery, but also watching students become scientists, and very, very exciting to see that process on both fronts.
So now you've given us a turn from the justifiably depressing part that we were talking about how much soil we are losing, to how there may be solutions in some of this. And that is what so many people who are watching this evening want to know, is where are our solutions? What can people do individually in their home environment? People are talking about gardening and composting, and what kind of legislation can we ask for? So I wonder if you could talk for a few minutes about your vision for creating a constituency for soil and for supporting practices that would allow soil to be conserved and protected.
Well, the great news in this very sad story of soil is that we know how to stop soil erosion. And we've actually known that for a long time. And that's where the indigenous cultures that you asked about come in, is that there are cultures who have been farming the very same land for 2,000, 3,000, 4,000 years, and their soil is still healthy and producing. They're not moving from land to land. They're farming exactly the same spots. So if that's possible, the question is, why can't we do it in modern agriculture if there are people doing it today who have done it for a long time? And the practices are really pretty simple. And if you look at all the different agricultural systems that are stable and sustainable, they all pretty much use the same process. And so one is not to till the soil. So we know how to do that. The second is to use cover crops, which means that when your main harvested crop is not in the ground, you make sure something's growing there so that the soil isn't taken away. That can also, when it's done right, it can eventually be very lucrative for the farmers, because it can either produce a second crop or it can be incorporated into the soil and reduce the need for fertilizers. So no matter what they do with it, there are benefits of the cover crops. And of course, in the Midwest, where we have these very long winters, the soil can be open and bare, can be plowed and then left bare for as long as 7 or 8 months of the year, between harvest in the fall and planting in the spring. That's a long time for soil to be exposed to wind and water that can erode it. And then the third is intercropping, which has been used in traditional agriculture across the world. And that's where you simply don't plant one crop, you plant several kinds of plants. And a group in Iowa has done an amazing job of showing that you can plant your cornfield pretty much the way you normally do in, the rows very intensively, and treat the soil in all the ways that you normally would, but just take 10% of the corn out of production and replace it with strips of prairie plants, the plants that gave rise to these beautiful deep soils in the first place. And that will reduce erosion 90%. 90%. And so that's a very small sacrifice of corn to save your soil for the long run. So the problem with that is farmers, their crop insurance will be reduced by 10% if they plant 10% less corn. Well, farmers can't afford that. Farmers work usually at a very, very small margin, and often in many years will lose money. And so the challenge there is, how do you make it feasible for farmers to do that? And that was something I wanted to do when I was in Washington, and it was a morass. Trying to change crop insurance is really tough. But that's where we need to work, is places like crop insurance, to give farmers the incentive not to do the bad practices and to engage in the good practices. So in that case, engaging in the strip cropping or planting cover crops. And so several people have proposed ways of incentivizing farmers to take care of their soil. And instead of giving them, for example, crop insurance, what if we gave them soil insurance? And it was based on not how much crop they produced, but how much their soil increased in health over time. And with that, of course, would be, and then if their crop failed, of course, they would get support from the insurance, but they probably would need that support a lot less, because if they have healthy soil, floods and droughts won't have as severe an effect on the soil.
So implicit in what you just said is a kind of a tension between how much do we ask policy to do and what practices do we choose. And several questioners coming in, several commenters have posed questions that I am noticing about those. Jenna Lasky asks, what kind of legislation do we need in order to protect soil? And conversely, Sophie Anthony asks, if we institute practices that are more like indigenous practices, are we in any way squelching innovation? So how do we walk our way between these two poles while at the same time keeping this lodestar of protecting soil in mind?
Yeah, they're both great questions. So I think any kind of legislation that will reinforce farmers who are trying to build carbon and organic matter in their soil will help. And some people think that carbon credits will be the saving grace. I'm not so sure about that, but that is one way that farmers can actually make money on the carbon that they're putting into the soil. The more carbon, the more income they get from big companies buying their carbon credits. So I think that is a very informal way between companies and farmers, rather than going through government, although I'm sure governments will get involved and develop policy around carbon credits. But any policies that affect crop insurance or give farmers subsidies for their land should be based on what they're doing to promote the health of that land, and not just paying them, assuming that they're going to be taking good care of their land. There are some good programs that do that, but they don't work hard enough, because unfortunately, the USDA doesn't have the resources to make sure that the farmers are coming through on their end of the deal and really practicing soil conservation. I don't really see how soil conservation is likely to squash innovation. I would say the opposite, that classical European American agriculture is squashing innovation. The row cropping that we do the same every year, and we put the same fertilizers and the same pesticides on. I don't see a lot of innovation coming from that. The innovative farmers that I see across the world are the ones that are trying new approaches, that don't involve what I think of as the industrial kind of farming, and really look at the whole ecosystem, the soil and the plant, and perhaps animals that live in symbiosis with the soil and the plants. So I think that's where a lot of the innovation is coming from in agriculture, very often from farmers who have been trying new methods to enrich their soils, to increase their yields. And I give some examples of Wisconsin and New York farmers that are doing amazing things to enrich their soils and not losing money. In fact, they're gaining income because their crops are more stable and less likely to be destroyed by these severe weather events when the soil is healthy.
You know, I just have to mention that just a couple of days ago, I'm in Atlanta. We had extraordinary winds here over the past couple of days, and a fantastic multi-species regenerative agricultural farm in South Georgia, White Oak Pastures, posted a video of their fields with cover crops on them, perfectly green and stable, and the soybean field next to them completely bare and the topsoil blowing away in the wind. It was the most perfect visual for what you're describing right now. And so we're getting close to the end of the hour, and I want to hear you describe your concept for how we build a campaign to save our soils. I want to mention that one of the people who has just posted a comment, Carson Bowl, asks, what have you learned, especially since you worked at a policy level, about the difficulty of making change at the institutional level? Change is hard. How are we going to do this?
Well, I think that's a great question. It is hard, and policy change is hard. It means getting it on the agenda of people in power. I was very heartened when President Biden, in his very first speech as president last year, talked about cover crops and paying farmers to plant cover crops. Pete Buttigieg, who was campaigning for president the year before, in one of the debates, talked about how we have to preserve soil in order to fight climate change. So I think there is a little bit of awareness that the soil is this important resource that we need to protect, creeping into the public consciousness and the consciousness of policymakers. So I think what individuals can do is make sure that policymakers, whether they're in their state or not, the important ones are, for example, on the Ag Appropriations Committee, who are writing the next farm bill, to make sure that those senators or congresspeople are aware of how much the public cares about soil and wants it to be preserved. And it won't take very many strokes of the pen to make a big difference if they're the right strokes. So that's one thing that I think can be done, is just pressure from consumers and people and farmers who want to be reinforced for protecting their soils. A lot of farmers want to do other practices. They just can't afford to either make the change, or they don't have either the equipment or the resources or the training to do it. So we have to provide all of that for farmers, because they clearly don't have the margins to support taking big risks and doing big experiments. So I think another thing we can do is support farmers directly. So community supported agriculture, I think, is a very important part of the American food system now. We should all be supporting that kind of agriculture, particularly on the farms that are doing soil conservation and are protecting their soil. Ask that question when you're buying produce, for example. Is this grown in a soil sustainable system? And that leads to one more sort of global change that I think could pressure farmers to change their practices, but reinforce them for changing their practices. And that's a consumer effort to develop a new kind of food, or a food label that would label food as soil safe or soil protective. And either we could charge a premium on food that is not raised under those conditions, or we could perhaps charge a premium for, as long as it went to the farmers, on food that was raised in a soil sustainable way, and somehow get the funding to the farmers so that they're reinforced for doing the right thing. And that's the key thing, is to reinforce the farmers, not the food processors or the marketers, but to get that extra income to the farmers themselves.
So I'll make my last question. You are at a university, heading a university institute. This is a program of a university center, the Center for the Study of Human Health at Emory. We have a commenter asking, what can students do to support the social movement that you envision that will support soil and return attention to soil? What is this younger generation coming up? What can they contribute?
Marvelous question. So on your campuses, you can demand that the food that's served on the campuses is food that has been produced under soil safe conditions. And many universities have contracted with community supported agriculture or organic farms or other kinds of farms that will very locally provide the food. And that is great for several reasons. Locally grown food is transported shorter distances, therefore uses less fossil fuel for transport. But you can also have more of an oversight of the kind of agriculture that is being used to produce that food. And you can choose the farms that are really paying attention to their soil. So that's something that students can demand. They can choose their colleges and universities by those kinds of practices. Is this a sustainable campus? And part of being a sustainable campus is buying food that does not destroy the soil. I think also doing practices on campuses like composting. You know, we waste or throw away about 1/3 of the food that we purchase in most settings. Well, what if we composted all of that and returned it to the soil? That's a lot of carbon going into the soil. It's also a lot of healthful material that will enrich the soil. So those are the kinds of practices that I think are very, very local that students can play a role in. And then, of course, growing crops and trees, planting deep-rooted perennials in any environment will help. It may be a small incremental change, but every bit helps. And there are so many people removing trees and removing deep-rooted perennials. We need some compensation for that. And that's something that anyone can do.
A stirring call to be defenders of something so basic that we barely think about it, the soil beneath our feet. I think that's all we have time for, but Dr. Handelsman, thank you so, so much for this fascinating hour. And thanks to all of you for listening and interacting with us. Please consider buying Dr. Handelsman's book and visiting her website, Soil Rocks, and the website of Tiny Earth. All of the links are in the ticker that you see on the bottom of the screen, and we'll also add them to the comment feeds of all of the platforms that you are watching this on. And please consider joining us next month. On April 19th, I'll interview Dr. Emily Willingham about her new book from Basic Books, which is called The Tailored Brain. From ketamine to keto to companionship, a user's guide to feeling better and thinking smarter. That's on April 19th, same time. Until then, I'm Maryn McKenna, from me and from the Center for the Study of Human Health at Emory University and the Georgia Center for the Book. Thank you for joining us. See you next month.